even my and my PhD scholars are working on the medical image processing. Okay. Now, as I said earlier about the deep learning, I don't want to discuss again, but I want to tell that the deep learning mainly it is an artificial neuron is the building block of deep learning. Okay. Now this artificial neuron, the inspiration comes from the biological neuron. So first let me discuss what is a biological neuron and then I will discuss about the artificial neuron, how they are relevant to each other. Now, I think maybe don't think that I'm teaching the biology. I am also poor in the biology. But let me discuss what is a biology neuron and then I will discuss what is an artificial neuron and how they are relevant. Now, if you look at this biological neuron, you have the dendrites. Okay, I think it is visible for everyone. These dendrites propagate electrochemical stimulation received from other neural networks to the soma. You have the soma, you have the axon, and you have the synapse. Now, soma contains nucleus and other structure that supports chemical processing of neuron. Here the soma is the pre-processing. I will discuss all these things in detail. First, let me discuss this biological neuron. And you have the axon, is a portion of a nerve cell that carries nerve impulses away from cell body of neuron, and you have the synapse which passes an electrochemical signal to another neuron or to the target electrical cell. Now I will come to this artificial neuron and I will discuss what is the role of dendrites, soma, axon and synapse in detail. Now coming to the dendrites are your input, x0, x1, x2, so on, xn, all these attributes of a particular data is nothing but the dendrites. Now using these variables x0, x1, x2, so on, xn, you will go for the soma. Soma is the pre-activation function. We have two types of activation function. One is the pre-activation and post-activation. Okay. Now here usually you will go for the aggregation. Okay. x0, if as there are no weights, so I can say that x0 plus x1 plus x2 plus so on xn. That value you will give to the g of x and then you will go for the activation a of g of x, which is nothing but the axon, and finally you will get the output synapse. So mathematically we can represent the g of x is the summation of all the inputs. So that's why I have written summation of I is equal to 0 to n of xi. Is it clear? Now I will discuss various artificial neural networks, such as we have the basic one is MP neuron, we have the perceptron, and then we have the sigmoid neuron. First, let me discuss about the McCulloch neuron, which we will simply call it as MP neuron. Now, in this MP neuron, if you look at the previous one, when we are discussing about the artificial neuron, we have represented the same diagram. Now let me discuss in a simple way. The same example I will give. Okay, you have whether the ball is pitched in the line, whether it has hit in the pad or not. If it has hit in the pad in a proper line, whether the ball is hitting the stumps or not. So all these things you are given here. Okay, x0, x1, x2, so on, xn. Okay, and then you are doing the g of x, and then you are doing the activation function a of g of x, and finally you are predicting the y. Now what is this thing is that we can, now if you look at here, we have the input, we have the output, x0, x1, x2, so on, xn is the input and y is the your output. Now how we can do it is that we will take a threshold value. Now let's take that with a simple example I will give you. Okay, you are writing, let's take that, suppose you are writing DBMS end semester exam. Faculty would have asked you, or the university have asked you to write 10 questions. Each question, let's take that is 5 marks. Then all the these 10 questions, they will correct it and they will give appropriate marks. And finally, if the sum is let's take the 35, then you are pass. I hope you are understanding this one. 10 questions are there, each question carries 5 marks, and If the complete total is 35 marks is the pass mark. If some student gets less than 35, he is failed. Now what you will do is that you will perform the sum of all these things. You will compare with a particular threshold. If the value is greater than or equal to threshold, then output you will get is 1. If it is less than the threshold, you will get the 0. So that is what, if all the summation of all these questions, if it is more than 35, I will say that you are pass. If it is less than 35, it is fail. Is it clear? It is a strict one. Is it clear? So that is what I am representing here. The simplified notation is y of x is can be either 1 or 0. It is simply doing the binary classification. All these things I will discuss. What is a binary classification, what is a multi-class classification, what is a regression, all these things I can tell you later. But I want to tell here the output can be either 0 or 1, whether it is pass or fail. So it can be either 1 or 0. When it will be 1, if the summation of all the values is greater than or equal to particular threshold, then it is pass, otherwise it is fail. Now you can easily say, sir, if you change the pass mark, then the number of students passed and number of students failed will vary. Am I right or wrong? So here what is the learning, what you need to learn exactly? The particular threshold value. If you know the particular threshold value, then obviously you can classify whether the student is passed or whether the student is failed. So that is what I told you earlier also. The g of x will do the aggregation and a of x will do the activation. Okay. I hope it is clear. If you have any doubts later, I will clear them. Now, what is the summary? Now, I will talk the machine learning model or the deep learning model with 6 buckets. What is the 6 buckets I will discuss? Then I will discuss each one with respect to the MP neuron. Now, whenever you are taking any deep learning model, first thing is that your data is very important. Okay, what kind of data you are taking, whether it contains only binary values, whether it contains real values, what kind of data it is there, that is very important. And then once you have the data, what you want to do, what task you want to do, whether you want to do the binary classification, whether you want to do multi-class classification, whether you want to do the regression, what task you want to do, that is very important. And then you need to design the model. Okay, how many hidden layers you want to have, how many ReLU activation functions you are using, what kind of polling mechanism you are using, all these things you will model it, and then you will train the things, and then during the training you will do some loss function. Suppose let's take that I am teaching deep learning to you all. When I am teaching to you, after the talk, if I ask some questions, then you may answer some of them or you may not answer some of them. So that we will call it as a loss. Suppose even when I am teaching to my kid ABC, when I am teaching her, parallelly she is learning and she will do some mistakes. That is what the general learning. If I teach her more number of times, then the number of errors she will do will become less. Am I right? So that is what we will say, that more training is required, or training on various data is very important. So during the training, we need to compute the loss. And our final goal is that the loss should be almost equal to 0. Am I right? Obviously, when I am teaching, suppose 10 times, obviously if I ask any question, I will expect that all my students will answer. If they could not able to answer, if they are getting the doubts, again I will teach. Okay. Now, the learning, how you are able to learn, because finally you need to go for the less loss. So how you are training, and once you have trained on the particular training data, I will go for the testing. So in the class I will ask some questions, and even I will give you some assignments so that you will learn in a better way. At the end of the semester, I will give some questions which I have never asked you in the class. Am I right? This is a way we will do, so that I will check what is the student's performance. That is what the evaluation. So you will train the model using the training data, and then you will compute the loss, and then you will do the learning, and so that the loss will become minimum. And during the testing, you will take the test data which was not used during the training, and then you will analyze it. Now this one of the metric is the accuracy. The accuracy can be computed as true positive plus true negative by true positive plus false positive plus true negative plus false negative. Then maybe some BTech students, maybe some faculty can understand what is this true positive, what is the true negative, all these things. But from the student's point of view, I want to tell what is true positive, what is true negative, what is false positive, what is false negative. All these terms will come in the confusion matrix. That's why it is very confusing also. That's why they even kept the name as confusion matrix. First, let me discuss what is a true positive. Even it is not there in the slide. As you are the BTech students, I am discussing this one. True positive, I will discuss. I think everyone loves the cricket match. Even I loves the cricket. So I will discuss the simple thing with this cricket match example only. Let's take that you are a fan of Yuvraj Singh. Okay, everyone know that everyone will loves the Sachin, but let's take that I am a fan of Yuvraj Singh. Yuvraj Singh is batting. Okay, when your favorite cricketer is batting or bowling, you will always predict for the best. Suppose let's take that Yuvraj Singh is batting against Broad. Okay, then obviously your prediction will be, as a fan, the Yuvraj will hit a 6. You have predicted that Yuvraj Singh will hit a 6 in the next ball. Okay, and he has hit in the 6. So your prediction is correct and the output is also correct. So it is called as a true positive. I hope you have understood. Your model, I'm just giving as an example, you and your output. Let's take that you have the data and you have given the data to the model, your ground truth value and the model predicted value we will check. Now the model has predicted as true means positive. Let's take that Yuvraj Singh will hit a 6. That is what the model has predicted, and he also hit in the 6. That is called as a true positive. Or I can say that Sachin has been out, means umpire has given him as not out, and even replace also saying that he is not out. Then it is a true positive. Now you can ask me what is true negative. As a true negative, I thought that by looking at this Yuvraj Singh batting, I thought lot of people will predict that okay, he is not hitting the first 10 balls. So you will say that, and suppose let's take that, I don't want to specify the bowler name. Suppose someone is keep on bowling the bouncers, then a lot of people will predict, the cricket lovers will predict that okay, they are bowling only bouncers and it is a test match and it is a green pitch in an Australia conditions. Then what you will say, Yuvraj Singh will out. But I am a cricket fan, I will never say that Yuvraj Singh will out. But let's take that you have predicted that Yuvraj Singh will get out in the next ball, and even he was out also. We will call here it as a true negative. Means you have predicted some negative thing, and even the output is also negative. Means your prediction and output both are correct. So here we will call it as a true negative. Now I will tell you what is the example for a true negative. I am not a corona patient and the corona test also came it as a negative. Then it is a true negative. You can ask me what is a true positive. I am a corona patient and the prediction also given it as a corona. Then I will say that it is a true positive. See, what is you are calling it as a positive, what you are calling it as a negative, means the data labeling it will be different. Okay, now I will give an example for the false positive. Okay, false positive means Broad is bowling. You have predicted that Yuvraj Singh will hit a 6, but he was out on the next ball. So this is an example for the false positive. Your model has given it as a positive, but the real correct ground truth value is negative. So this example is a false positive and the opposite one is a false negative. You have predicted that Yuvraj Singh will out in the next ball, but actually he has hit in the 6. This is a false negative. But when you are computing the accuracy, true positive and true negative are the correct. So true positive plus true negative by true positive plus true negative plus false positive plus false negative. This is, we will call it as an accuracy. So I hope you have understood this confusion matrix. Okay. Now let me come to the summary of the MP neuron. Okay. The data we will take in the MP neuron is the binary values, which is in the terms of zeros and ones. And the task we want to do here is the binary classification, whether the output is 0 or 1. And the model, simple model we will use it is the what you called the simple aggregation we will do. And what is the trainable parameter here is the theta. And what is the loss function we will take? yi minus yi hat whole square. Now what is the yi is the actual value and yi hat is the predicted value. Okay. Now yi is the ground truth, yi hat is the predicted value. Now you need to compute the loss. Now you can ask me, sir, why we are doing the whole square? Why can't we simply say yi minus yi hat only? Now let's take that. I will tell you one simple example. Somewhere you are getting the loss as -1, somewhere you are getting the +1, then -1 plus 1 will become 0, then final loss will become 0. Are you able to understand? In some parameter you are getting the loss as -1 and next iteration you are, or I will tell you, in some data points you are getting the loss as -1 because it is binary values 0 and 1, so you will get either 0 as a loss or -1 or +1. Okay. So now at some data points you are getting the value as -1 and some data points you are getting the +1, then overall loss will become 0. But in both the cases you have done the wrong. Is it clear? Or let me give an example. Your input yi means the actual value is 0, but your model has predicted 1, then 0 minus 1 is -1. And another way is that your ground truth value is 1, but your model has predicted 0. In both the cases the model has done the wrong, so the error should be 2. But if I do the yi minus yi hat only, the error loss will become 0. Then simply you can say that by this time some students would have thought that, sir, I can use the absolute value. Am I right? Instead of squaring the loss, I can take the absolute value. Why? If it is -1 or +1, if I give the absolute value, it will become a positive number. But when we are using the deep learning models, we will use the back propagation. We will differentiate the loss with respect to the weight. So the earlier one, whatever I have discussed, the absolute value, we cannot be differentiable because it is not a continuous equation. So that's why we will go for the square, which can be differentiable with respect to the weight. So that's why people will use the sum of square as a loss. And here what we need to learn, we need to learn only the threshold value, which is a theta, and how you will evaluate the model is the using the accuracy. Okay, meaning is that how many inputs you have given, out of that one how many was correctly predicted. Now what is the drawbacks or the limitations of the MP neuron? It accepts only boolean inputs. Always our data is boolean inputs only? No, it can be, and real numbers are also possible, like 0.6, 0.7, like that also possible. Not always our data will be only 0 and 1. And it can be useful only for the binary classification, true or positive. Is it clear? Because in a cricket match also, whether 6 and out only, both are the, it can be either 0 or 1 2, 3, 4 runs, 5 runs, 6 runs are there. Am I right? So that will come in the multiple classification, but binary classification 6 are out, are not out or out. That only we can do using the MP neuron. And here the learning is linear with fixed slope, and only adjustment parameter is the theta. So these are the limitations of the MP neuron. Then people have gone for the perceptron. Now if you look at the difference between the MP neuron and the perceptron, here there are weights W0, W1, W2, Wn, but here there are no weights. Meaning is that what is the pitch condition, whether the ball is a red ball or a pink ball, whether McGrath is bowling or what you called Steve Waugh is bowling. Am I right or wrong? So based on the input and the weights, we have to take the final decision. So here we have x0 and the particular weight, x1 particular weight, x2 particular weight is there. Okay. So what is the input here? x0, x1, x2, x1, xn is the input, and the output is again the y. Now what we will do here is the aggregation. How we will do is that the weight into the xi. So from I is equal to 1 to n, because the first one we will call it as a bias. Okay. So wi into xi from I is equal to 1 to n, if it is greater than or equal to particular threshold, then the output will give it as a 1. The output will give it as a 1 means neuron has fired. If it is 0, when it will become 0? If the value is less than threshold, then it will be 0. Is it clear? So this is the way it will work. Now what is the limitation here? The inputs are the real numbers and the weights are also the real numbers, but the output again is a binary classification, meaning is that it is 0 or 1. So the main difference between is that introduction of numerical weights for inputs and mechanism for learning these weights. Because here what are the things we need to learn? We need to learn the weights and also we need to learn the threshold value. Whereas in earlier only we need to learn the threshold value. So that's why the learning algorithm will vary in the perceptron as compared to the MP neuron. Now as I said earlier, the data here it is, the real inputs are accepted and the data need to be standardized. If the data is not the standardized one, okay, then we need to standardize, we need to make the data from 0 to 1. And what are the tasks we need to perform is that we can do the binary classification. And what is the perceptron model we had to take it is that this is the model. In the earlier slide also I have discussed. Again the loss is the squared error loss only. Okay. Only change it has happened is that weights are there and the inputs are real numbers also can be taken. And what is the perceptron learning algorithm is that if it is convergence, means whether the number of iterations are happened or if the loss is 0, then we will stop this algorithm. Otherwise we will take whether x belongs to x0. Here the x0 is the inputs with label 0, x1 is the inputs with label 1. Okay, then accordingly you will change the weights, because we are representing as w is equal to w plus x or w is equal to w minus x. We are changing the weights and finally we will find the particular weights for which the loss is less. And then during the testing we will again compute the accuracy to know how the model is performing on the testing data. Okay. Now what is the summary of the perceptron? The summary is that it takes only real values and again we can perform only the binary task and the loss function, and the learning algorithm is changed because every time we need to update the weights and also the threshold. Okay. And what is the again the limitation is that it can be used only for the binary classification only. So now we will discuss about the sigmoid neuron. Now the earlier two models, they are, we will call it as harsh models. Suppose let's take that. With respect to the student and faculty, I will tell. Suppose someone has scored 34.5 marks. Okay, the pass mark is 35, then student will say that sir, 0.5 only I lost, 34.5 you can make it as 35 and you can pass me. But coming to the MP neuron and the perceptron models, what is happened there? If it is the pass mark is 35, you secure 34.9 also, it will predict that you are a failure. Means you have failed in the subject. Am I right? So that's why we will call them as a harsh model. Even if you got 34.9 out of the threshold value is 35, the model will say that you have failed in the subject. But as a teachers, we are very good people in the earth. Even if someone got 34 also, he is in the border. For the student benefit, we will give one more mark and we will pass him. So even the sigmoid neuron is not that much hot, it's not a harsh model. I want to tell you that one, it is a smooth function, continuous and differentiation function. Sigmoid neural is similar to perceptron except the activation function. Always the activation function only will change. And non-linearity has introduced in the neuron with logistic activation function. Sigmoid neuron is the basic building block of deep learning. Now CNN you are studying, okay, in CNN we will use the sigmoid neurons only. Collection of sigmoid neurons will become as a one deep learning model. I can tell you an example that I think everyone know the relation between the brick and a building. A collection of bricks, if we keep them in a proper order, we will get a particular building. So sigmoid neuron is the basic building block of deep learning. Now what is the activation function here we will use is the logistic activation, which can be represented as y is equal to 1 by 1 plus e power minus x, where x is summation of wi into xi. Is it clear? So again the input is a real number and the weights are the real number, and the g of x again is your g of x is simply x naught into w naught, x1 into w1 plus x2 into w2, so on, xn into wn. Now only the activation function here it is changing. That summation you are giving to 1 by 1 plus e power minus that value you will keep. Okay, so this is the sigmoid neuron. Already I have discussed that it takes the data as real data and data need to be standardized. But one thing we can do here is that we can do the binary classification and also we can do the regression. The regression, I will tell you one simple example. Like the based on the what is the house, let's take that if it is 2 bhk you need to pay some 6,000. If it is 3 bhk house you need to pay 10,000 rent. So based on the size of the house, the rent of the house will vary. Am I right or wrong? So that kind of doing is we'll call it as a regression. Okay, so again we will use the sigmoid neuron here. The loss function is sum of squared error loss only. The learning algorithm we will use it is a gradient descent algorithm. Okay, and the evaluation is again the accuracy or the root mean square error. Now let me discuss about artificial neural networks. What are the components of artificial neural networks? One is the sigmoid neurons, weights and bias, and the activation functions. And what are the layers is that we have three types of layers. One is the input layer, hidden layer, and output layer. The input layer accepts the input data. Hidden layer will compute the future extraction, and output layer will produce the results. We have various types of artificial neural networks such as feed forward neural networks, convolutional neural networks, recurrent neural networks, and autoencoder neural networks. All these things, if time permits, I will discuss each one in detail. First, coming to the feed forward neural network. It is the first and simplest type of artificial neural network. This network feeds neuron activations in forward direction. Error propagates in the backward direction. Now, let me tell you with simple example. Okay. Now the input layer is taking the inputs and the hidden layer will process it and finally it will give the output. Now let's take that. I will give it a simple example. The input is the teaching. Okay. What will happen normally in a college or institute? The faculty will teach to the students, okay, for a 5 months or 6 months or 4 months, and then institute or the university will conduct the exam, and then students will write the exam. Finally, the student may pass or fail. Now let's take that students have studied the subject and they have written the exam, and most of the students have failed in the exam. Then obviously the management or the HOD will ask why these many students have failed. Then faculty will say that the students have not studied properly. The students will say that the subject was tough. So people will blame on the previous things because the input layer has given to one hidden layer only I have represented, but we will have several hidden layers. So input layer is going to the hidden layers and finally it is coming to the output layer. Now, what is the way the model will work? I will discuss with a simple example. Now xi is the input here and the wi is the weight here. So you will do xi into wi and then you will apply a activation function. Already I discussed that each neuron will consist of aggregation function or pre-activation function, and then it will have the activation function. Okay, so you will have the g of x and a of g of x also. So in the pre-activation function you will do the aggregation xi into w I1, and then you will give to the activation function. That activation function I am representing it as A1, and then this A1 again you will multiply with Wi because for this neuron the output of this one will act as an input and the corresponding weight. Is it clear? So this A1 into this WIT you will do, and again you will apply the activation function, then finally you will predict the things. So this is the way the feed forward network will work. Then in the how you will learn, because we will always learn from the mistakes. So again you will compute the loss with respect to the weights and then we will update the weights. Here the final goal is that you need to find the appropriate weights such a way that your loss will be minimum. Okay, so you will find the error and you will differentiate the error with respect to the weights and then you will update the weights. Okay. So this is another example of the feed forward network where I have represented multiple hidden layers. This is a hidden layer 1, this is the hidden layer 2. So that is what I am saying. The 0th layer is the input layer and then you have the L minus 1 hidden layers and the Lth layer is the output layer. Okay. So this layer output will act as an input to this layer and this layer output will be given to the output layer. Okay. Now what is the loss function we will use? It is the cross entropy loss function. I will not discuss much about this cross entropy loss function. Okay, it is already 11:15. Okay, and then what is the learning algorithm we will use? In the feed forward network we will use the learning algorithm which is gradient descent with back propagation. Means in the forward pass you are getting the output. In the backward propagation with respect to the loss you will update the weight. Suppose let's take that students have studied for 2 hours per day and faculty has conducted a test, class test faculty has conducted. If a student got less marks in the class test, then what he will do? Okay, for this subject, if I studied only for 2 hours, I may not get enough marks. So then what he will do? Next day he will study 3 hours, 3 hours every, that entire next week every day he has studied for 3 hours. Then again he has written the class test. Then again he got less marks, but compared to the previous marks it was more marks, but till he was not reaching his goal. Then again what he will study? He will study for 4 hours. Okay, for 4 hours, if he is getting good marks in the class test, then he will continue the studying for 4 hours and again he will write in the end semester exam. So you need to update the weights based on your loss during the training time. This is what the way you will update the weight. Wt plus 1 is equal to Wt minus mu into the derivative of the W2 with respect to the loss. Okay. This one we will call it as a learning rate. Okay. This learning rate can be static or it can be dynamic. I will discuss them in the next video. Sorry, not next videos, in the next slide. Then what are the limitations is that it takes lot of time to navigate the regions having the gentle slope. This is because this gradients in these regions is very small. Maybe you did not understand anything from these 2 points. I will discuss with an example. Suppose let's take that you have done the derivation. If the derivation value is very small, how much rate the weight will update? The weight updation also will become very less. Am I right or wrong? Suppose let's take that simple example. You have studied for 3 hours. You want to get 50 out of 50. Then you got only 49 marks. Then next day what you will study? 3 hours 10 minutes you will study, because the weight updation is now is small, because the loss is small, because your derivation is small and the learning rate is also small. Then weight updation, this entire value will be small. Then Wt plus 1 is almost equal to Wt. If you are updating the values very small, then to reach to the final weight you will take lot of time. Okay, that is what I want to say here. Now we will discuss various other learning algorithms. These learning algorithms are very important, because lot of people when they are reading the articles related to data science or deep learning, sorry, not data science, deep learning, then they will use these words called Adam, N-Adam, all these things. But if you don't know what is Adam, what is N-Adam, you cannot understand anything from the paper. So this Adam, everything will come to this one. We will discuss each one in detail. Now, those learning algorithms are broadly classified into 2 types based on the learning rate. Okay, if the learning rate is static, we will go for the gradient, momentum based gradient, NAC, NACLO, accelerated gradient descent algorithm, all these things. Now I will discuss this momentum based gradient descent mechanism with a simple example. Let's take that I am in Chennai. I want to come to Bapatla Engineering College. I am driving my own car. I forgot my mobile phone. If I forgot my mobile phone, I cannot look into the GPS and I cannot use the Google map to see the route and come to the Bapatla Engineering College. Then what I will do? I don't have a phone. I am driving my own car. I will drive for 10 kilometers. I will ask some person if how to go to Bapatla Engineering College. Then he will say that go straight. You have come to the national highway, go straight, then you will reach to the Bapatla Engineering College. Then again I will drive for 10 kilometers. Again I will stop my car and again I will ask someone how to go to Bapatla Engineering College. Then again he'll say that go straight. Next time what you will do? You will drive for 20 kilometers, because everyone is saying that go straight, go straight. So you will drive for 20 kilometers and then you will ask someone. He again say that you go straight. Now next time what I will do, I got the confidence, everyone is saying that go straight, go straight. I gone 1,000 kilometers now, just an example. Then what will happen if I go 1,000 kilometers? I would have crossed the Bapatla Engineering College. Am I right? So now what I have to do? Again I will go 1,000 kilometers. I will ask someone, oh, he will say that you crossed the Bapatla Engineering College, you go back. Then again I will take the U-turn. So this is the way the momentum based gradient descent will work. Okay, so the weight updation will even happen with respect to the history. So we will update with respect to the history. That is what I am saying. We will even ask someone, everyone is saying straight, straight, straight. So then I will update a large value, means I'm crossing some 100 kilometers, then I'm going 1,000 kilometers, like that I'm doing. So now what is the problem here is that sometimes you need to take the U-turns, but as compared to the gradient descent, momentum gradient based descent mechanism will work better way, means that it will converge fast as compared to the gradient descent mechanism. So that is what, even in the regions having gentle slope, momentum based gradient descent is able to take large step because the momentum carries it along. But what is the drawback? It takes the U-turns. Now we have the Nestro accelerated gradient descent, we will call it as NAZ. Now here what I will do is that we have understood that momentum based gradient descent, you are taking the U-turn. So here what the people will do is that they will travel 10 kilometers and then they will ask the a person, if he is saying go straight, then there after there reaching there, I will compute the loss, means the derivative of that one, then I will update the weight. So here the U-turns will become less. Is it clear? Because every time you are going particular distance and you are asking the particular person, and based on that one, there you are computing and you are taking the value. So but only problem with the momentum based gradient descent and NA is that fixed learning rate. Okay, this new value is constant. Okay, but it should be dynamic in nature. Why it is so? Now let's take that. It's simple. Let's take that you are studying a particular subject. If the particular subject is taught for an entire 4 months, then your concentration can be deviated for particular amount of time, because in a class, every class a student may not listen with the same intensity. Am I right or wrong? Because he know that this subject I can learn for 4 months, then only I have to write the exam. But suppose let's take that your university come into the picture that you need to learn the subject for a 1 week and then immediately the exam will be happen. So this 1 week, all the classes you will listen with more concentration. So that's why your learning rate has to be adopted dynamically. Meaning is that sometimes your learning rate can be small, sometimes your learning rate should be large. Why I am telling this point is that in your data, okay, you can have the sparse data, means in your future you have the sparse futures and you have the dense future, means in a future you have the lot of values are there. If the null values are less, then we will say that it is a dense future. If it is null values are more, then it is a sparse one. If the null values are more, meaning is that with less values you need to learn lot of things, there your learning rate should be high. If large values are there and null values are less, then with large data you can learn the things, so your learning rate should be less. So you should have the dynamic learning rate as compared to the fixed learning rate. So based on that one, we have the ADAGRAD, RMS prop and ADAM. As it is already 11:30, I will not discuss in detail about these algorithms, but nowadays we are using the ADAM and ADAM, all these things. okay, as compared to the gradient descent, momentum based gradient descent. If you are reading any article related to the deep learning, you can see this Adam and Adam, all these things. Now I will discuss various activation functions. Till now I discussed the only one activation function, which is a logistic. While I was discussing about the sigmoid neuron, I discussed about this logistic function. Now we will discuss each one and we will identify what are the limitations of it and then which activation function we should go ahead. Now this logistic activation function, already I said that it is 1 upon 1 plus e power minus x. Now this value will be in the range from this, if you look at here, it is minus 10 to 10. Just for an example I have told you. Okay. Now what is the problem here is that one is that output is not zero centered. If you look at it, is not touching the zero. And the vanishing gradient problem is there. What is this vanishing gradient problem is there? If you reach minus 10, after minus 10 you cannot go further. If you reached plus 10, you cannot reach further. Is it clear? So your stopping points are minus 10 to 10. If you are within that range, it is okay. So then your weights will not be updated, then you will lose the data and you will get the vanishing problem. Means the neurons are died. They are not updating the weights. And another problem is this logistic function is it is computationally expensive because you have the e power minus x, which is computationally expensive. So that's why people will not go for the logistic activation function. Then another activation function is tan h. We have the ReLU, we have the leaky ReLU. First let me discuss the tan h. The tan h is tan of h of x. It will be this. This is the pictorial representation of the tan h. Okay. Now what is the problem with the tan h is it is output is zero centered, but it is also having the vanishing gradient problem, and even it is computationally expensive. Why it is that? It is the tan h activation function formula can be represented as e power x minus e power minus x by e power x plus e power minus x. So that's why again this e power x terminology is there. So that way it is computationally expensive because for every neuron you need to use this tan h. So that's why it is computationally expensive. So it will take a lot of time. Then people have gone for the ReLU. The ReLU, I think everyone would have listened about it. How you will compute the value on the ReLU is you will use the max of 0 comma x. If x is a negative value, you will get the output as 0. If x is a positive value, you will get the x. Is it clear? So that's why for the negative values, it is generating the output as 0. For the positive values, it is generating with respect to that one. If it is 10, it is generating the value 10. If it is 5, it is generating the 5. So can you tell me one thing? It is saturating towards the negative side. If it is minus 10, minus 20, all these things, it is producing the 0. But if it is a positive value, if it is 20, it will produce the value 20 here. So in the positive direction, it is not saturated. Is it clear? So it does not saturate in the positive side and it is computationally efficient, means it will take less time because you need to apply the max function only. Now people have identified the drawback of the ReLU because it is saturated in the negative side. To overcome that one, in the ReLU, what they have done is that they have computed the max of 0.1 into x of x. So if it is a negative value, it will do the 0.1 into x, whereas here it is giving the 0. Is it clear? So that's why output is close to 0 centered and it does not saturate in the positive side and negative sides. Okay, so and it is even computationally efficient. Now what is this output is 0 centered means? I will discuss, actually if it is a class, if I teach using the blackboard, I would have discussed with an example, but it is a PPT. I will not discuss about what is this output is close to 0 centered output is not zero centered. But you can understand that if it is output is zero centered, then the weights will converge fast as compared to the output is not zero centered. Now the next thing is that when I was discussing about the perceptron, okay, you can see these weights W0, W1, W2, so on, Wn is there. These weights we will only give initially. Am I right? Then we will update those weights. Is it clear? So these weights, how to give them? As we are giving the weights, how we should not give those weights? Weights should not be all zeros. Okay, weights with same values you should not give. All weights you should not give the same values. If you give very large values also, then some of the neurons may die. Now you can ask me, sir, why you should not give all the weights to the zero? Why you should not give all the weights to the same values? Then if you give them, there is a symmetric problem will happen. What is this symmetric problem? I will discuss with this example. Suppose let's take that, okay, here weights are there which are same. Then your activation function, okay, now this weight and this weight is same, then this activation function and this activation function also will produce the same values. Okay, so then the learning will not happen in a proper way. So that's why you should not give the weights with all zeros. You should not initialize all the weights to the same values. You should not initialize the weights with the large values. Okay, because you can do the normalization. Standardization you can do for the input, but you cannot do the standardization for the weight. So you should not give the large values to that one. So that's why two scientists have designed the how to do the weights initialization. One is the He initialization and another one is the Xavier initialization. Now this He initialization is nothing but the how to you have to initialize the weights. The number of neurons in the L minus 1 layer. Is it clear? Let me discuss here. The weights here you should give because here only you are giving the weights. Am I right or wrong? Here you are giving those weights. So these weights, how you should give it is that based on the number of neurons in the previous layer, L minus 1 layer, based on that one you should give. Okay. Okay. If it is He initialization, you will do 2 by number of neurons in the L minus 1 layer. If it is Xavier, you will do 1 by number of layers in the previous number of neurons in the previous layer. Now, where we can use this the He initialization, where you can use this Xavier initialization is that if you are using the ReLU or Rekey ReLU, then you could go for the weights initialization based on the He initialization. If you are using the logistic or TANH, you can go for the Xavier initialization. Okay. Now let me discuss about regularization. Okay. What is a regularization? What is the bias? What is the variance? Now you can tell me one thing. In this algorithmic model or in the statistical model, we know that y is equal to f of x is the true relation. Am I right? Y is equal to f of x. But we don't know what is the complexity of this function. Whether it is polynomial or what is that one. Now suppose let's take that if it is a simple model, we know that the simple model is y is equal to mx plus c. It has a one dimensional future vector, and whereas the complex models will have the so many weights, summation of I is equal to 1 to n wi into xi plus w naught, where w naught is the bias. Now multi-dimensional future vector. Okay, now what is this bias and what is this variance? Now If you take very complex model, then it will learn in a better way during the training. Is it clear? Suppose let's take that you know very well how to by heart the things. You have by hearted whatever the faculty has taught. But what is the problem with the by hearting thing is that in an exam someone has asked you a question related to application, then the student cannot able to answer. Is it clear? You have by hearted everything. If something is new is asked in the exam, you will fail in the exam. Suppose let's take that if the model is very simple model, if the model is very simple, then it could not able to learn in a better way during the training itself. If it is performing very bad during the training, during the test phase, will it perform well? No. Suppose let's take that during the class tests itself you are not performing well. Can anyone predict that you will do very well during the end semester exam? No. So if the model is very simple, then also it may not work properly. If the model is very complex also, the model will not work properly, means it will not give the correct results. Is it clear? So your model should not be very complex. But remember one thing, all the deep learning models are very complex. So they will go for this high variance and the low bias. But the ideal one is that low bias and low variance. Now let me tell you what is this bias and what is the variance. The simple model you have taken and you have given the what you called various data points you are given. Suppose let's take that you have a data of 10,000 rows are there. So what you will do, initially you will give 100 rows and you have trained the model and it has given the particular loss. Again you have given. So the simple models will go for the high bias. It will be lot of variance will be there. This is the way the bias will be calculated and this is the way the variance will be calculated. The simple model will have the high bias and the low variance, whereas the complex models will have the low bias and they will have the high variance. But the ideal model is that low bias and low variance should be there. So that's why we need to go for the regularization mechanisms. So that is what we will call it as overfitting and underfitting. This is the exact terms we should use, and always your model should be best fit. Overfitting means it is doing very well on the training and it is doing very pathetic during the test error. Okay, is it clear? Whereas the underfitting, it is doing very bad during the training and also doing the testing. But ideal one, what we want the training loss and the test loss should be minimum. So this is the way you should go for the best fit, which is low bias and low variance. So that is what here I have written. High test error data to the high bias is the underfitting. High test error to high variance is the overfitting. So now lot of students will ask me this question. Sir, I am getting high training error and high test error also. Then what should I do? Then you need to increase the model complexity and also you need to train the model for more number of epochs. My training error is low, but my test error is coming high. Then you need to give more data. Meaning is that during practice, this is the way simple people will say, sir, I am studying well and during class test I am performing very bad. Even during the end semester exam also I am performing very bad. Then obviously faculty will say that you need to study for more time. Suppose if you say that, sir, during class tests or during practice, I am doing less number of mistakes, but in the end semester exam, I am doing lot of mistakes. Then faculty will say that you take more examples. do different types of examples, because they are asking new questions you are not able to answer. So you need to do more practice questions. So that's why the solution for it is that add more training data. That is why we will say that you increase the data. Your data is not up to the mark, so that's why you are getting the high variance. Okay, so how you will improve the data is that you will do the data augmentation. Is it clear? Meaning is that you have the image, you will do the rotation, you will do the translation, all these things you will perform. Means you will rotate with the 90 degrees, 180 degrees, everything, and then you will increase the training data, and then you will train this model with more data. And then you need to do the regularization, such as L2 regularization, all these things. Or you can do the early stopping. What is this early stopping? Is that if you know that after reaching this best fit, you are doing the training error is less but testing error is high, so instead of going up to there, here itself you will stop. So you will stop the when you are getting the proper value, there you will stop. Even usually we will do this way. If you are reaching particular thing, we are doing the mistake, then that is the ideal case. We will see there itself we will stop for the next time. If it is low, meaning is that during the class tests you are performing very well, and you are during the end semester exam also you are performing well, then you are a perfect student. Then done. Now you can ask me one thing, sir, you said high, 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 low, low. Why you should not say this case called high and low? Now tell me one thing. During the class tests, you are performing very bad. Is it possible that during the end semester exam you will perform very well? Unless until you do the copying, it is not possible. Am I right? So that case we will not consider. Now we have the various regularization. It is a technique used to reduce the errors by fitting the function appropriately on the given training set to avoid the overfitting. Okay. So the regularization we have L1 regularization, L2 regularization, dataset augmentation, early stopping, dropout, batch normalization. Let me discuss each one in detail. Now in L1 regularization, till now we are what you called the loss only we are analyzing. But here with respect to the loss, even we need to check the summation of these weights. Even your loss should be less and summation of these weights also should be less. Because what is the problem with the overfitting problem is that your weights you have initially very large value such a way that your loss will become less, then it will become the overfitting problem. So in L1 regularization you add the absolute value of magnitude of coefficient as a penalty to the loss function. So your loss plus the summation of these weights, to that one you will differentiate such a way that your weight should not dominate this loss value. And in L2 regularization, you will do the add squared magnitude of coefficient as a penalty term to the loss function. So that is the only difference between L1 regularization and L2 regularization. Now, what is the data augmentation? I said that if you have less data, then it is very easy to training error to 0, but if you have more data, harder to drive training error to 0. Is it clear? So people will say that you produce more data. That's what I was saying. Deep learning models are data hungry models. They need large amount of data. But in real time or in the public domain, we will always get less amount of data. When it compared to the coming to the medical image processing, we will not have the large data. So then what we will do is that we will do the data augmentation, and then we will train our model such a way that it will perform well during the test data also. And even you can do the early stopping, and dropout is very important. Lot of people will use this dropout without knowing what is the dropout. Meaning is that few neurons, when you are training it, you will not use. If you are not using Even in the forward direction, even in the backward direction, they will not update. Now let's take that simple example. Okay, suppose a faculty has given a project and it is a group project. Now if it is a group project, what will happen? 5 students are there. Then each student will say that, first student will say that I will sleep, I will take rest, you four do, so that we will get a good marks. Like that everyone will think, okay. And finally what will happen? One of the student, even students are also very intelligent, they will select the group such a way that one intelligent student they will take, and another medium 2 students they will take, and finally 2 students will never work. Finally that intelligent student only will work everything, and finally all the students will get good marks. But what is this dropout is that you need to remove this. Usually this one is that you need to ask the topper you don't work, so that these 4 people will work very hard, they will learn the new things and they will do the project very well. Because you are a topper, I have the very strong confidence on you. Similarly, if all the neurons are working, then every neuron will learn the small things, they will not learn the good things. So that's why we will intentionally drop the few neurons, meaning is that we will give the inputs to the zero to that one. Obviously if you give the input to the zero, then it will not update further even in the background. Then that is the way, this is what it is, a technique that deactivates few neurons in the neural network randomly to avoid the problem of overfitting. Okay. And batch normalization is a technique that standardizes the inputs to the layers by recentering and rescaling. Till now we discussed that only inputs need to be standardized. But in the batch normalization, I told you that here in this figure I would have discussed this point. I told you that this neuron will get the input from this neuron. Output of this neuron will be act as an input to this neuron. Till now we have discussed that we need to standardize these inputs. But if you want to perform very well, even you need to standardize the outputs received from these neurons, because these outputs are acting as an input to this neuron. So even we need to standardize these outputs which are received from the L-1 layer. Okay. This is about the regularization mechanisms such as data augmentation, early stopping, dropout, and batch normalization. Okay. Now coming to the CNN, maybe a lot of students would have expected that CNN will come in the first slide, but it is coming in the last. Why I want to tell you that way is, lot of students will think that, or the lot of researchers will think that deep learning is only the CNN, RN, and all these things. Okay, ResNet, GoogleNet, they would have studied and they will say that I learned GoogleNet, so I know everything in the deep learning. But the deep learning, lot of students will ask this question also to me when they are doing the project. Sir, I have the data. Sir, can you tell me the model? How many hidden layers I should use? How many polling techniques I should use? Should I use the max polling? Should I use the average polling? Should I use the stochastic gradient descent? Should I use the Adam or N-Adam? They will ask, sir, can you tell me the model? I have the data. I will train and I will tell you the results. If I tell the model, even I don't know which model will work perfectly for this data. So that's why you need to do the hyperparameter tuning. Meaning is that for this data, how many hidden layers should be there? In each layer, how many neurons should be there? And what is the activation function should I use? What is the activation, means learning algorithm should I use? What is the way I need to initialize the weights? So you need to change these parameters, and then finally you need to check what is the loss you are getting, and then you should go for a perfect model which works for this data. So that's one we will call it as an hyperparameter tuning. So if you need to do the hyperparameter tuning, you should know what are the various learning algorithms, what are the activation functions are there, how to initialize the weight, or how should I not initialize the weights, for which kind of model I am using, what kind of activation function should I use. All these things they should know it. then only they can go for the better model. So now let me discuss. I think everyone know about the CNN. In shortcut, we will call it as a CNN, which is a convolutional neural network. The basic and important operation is here is the convolution. Is it clear? Is a class of deep learning methods which has become dominant in various computer vision tasks. It is designed to automatically learn spatial hierarchies of future through backpropagation. That is what we have discussed also. We need to update the weights with respect to the loss with respect to the weight. Also known as space invariant artificial neural network. It is regularized version of multi-layers perceptron. Okay. Now let me discuss about the building blocks of CNN. We have convolution layer. Okay. During this convolution layer only we will learn the futures, means automatically it will learn the futures. We have various types of convolution, one dimensional convolution, two dimensional convolution. Everyone, those who learn the image processing, they know this one as a filter. Am I right? This is your filter. On this input, you will apply this filter and you will learn. Suppose let's take that. This is my input and this is my filter. So what I will do, 1 into 1 plus 0 into 0 plus 0 into 1 plus 1 into 0 plus 1 into 1 plus 0 into 0 plus 1 into 1, 1 into 0, 1 into 1, they will do the total, you will get 4. That value you will keep. So this one, those who have learned the image processing, they will say that this is a filter. Now in the deep learning, you should know what is the appropriate filter you should use such a way that you will predict the results in a appropriate way. So this filter is nothing but your weights. This is what you will learn during the deep learning. Okay. Now we have the polling layer. The polling layer will do the, what is that? It will reduce the number of parameters. It performs a typical downsampling operation. It introduces a translation invariance to small shifts and distortion. Now I will discuss what is the max polling. Now let's say that you have the 16 by 16 matrix and you have taken, okay, you have 4 by 4 matrix, you have taken 2 by 2 as a filter. Now this part you will take, if it is a max polling, look at what is the maximum value here. You have 4, you have 9, you have 5, you have 6. What is the maximum value? 9. That value you will keep here. Now again you will take this one. What is the maximum value? 5. That 5 value you will keep here. Again you will take this block. Maximum value is 6, that value will keep. Here the maximum value is 8. So from a 4 by 4 matrix you have reduced to 2 by 2 matrix. So you are reduced the number of parameters here. If it is an average polling, you will compute the average of this one and you will keep it. And this is about the polling layer. We have the max poll, we have the average polling, all these things. So even in a network, whether max polling will work better or whether average polling will better, based on your data, you need to look at all these things. You should use the max polling and you check what is the error you are getting. If you are using average polling, what error you are getting. So then you have to do all these experiments to find the better model for the whatever the data you have. And finally you will have the fully connected layer. It is also known as a dense layer. Future map after the first convolution of polling layer is flattened to one dimensional because you have the 2 by 2, and all this one you will give to the dense layer, then it will make it into one dimensional. So one dimensional future map is mapped to produce final outputs of the neuron. Now listen carefully. Whatever the bird I have given, okay, that one we will do the convolution and we will do the max polling and then finally we will predict the things. Okay. So now let's take that I have given such an image here. Okay. And my model will give the output as Sachin or not Sachin. Now I have two neurons in the output layer. Am I right or wrong? So now how my output layer will work based on the probability. If the probability is high towards the Sachin, then I will say that this image belongs to Sachin. If my probability is high towards that he is not a Sachin, then my model will give that he is not a Sachin. Okay, so there you will use the softmax layer because the probability should not be a negative value. So that's why you will use the softmax, because sometimes the probabilities may be less negative value. So that's why you will go for the softmax layer at the output. Okay, and we have the popular variants of the CNN such as AlexNet, VZZNet, GoogleNet, ResNet. Okay, so each network, the number of neurons will change. If it is in ResNet, you have the ResNet 50, you have ResNet 32, ResNet 18, ResNet 34, you have ResNet 50. Means number of layers in the ResNet. If it is ResNet 18, I will say that 18 layers are there in the model. If it is ResNet 50, I will say that 50 layers are there in the network. If it is a Google net, the number of layers will be different. If it is a VCC net, it will be different. If it is an AlexNet, it will be different. But the complex one is the ResNet, because the number of layers will be more in this one. So it is 11:55 on a Saturday. I don't want to take much more time. Okay, so this is about the deep learning, but I should have discussed about this LNet everything, and I would have discussed the recurrent net, because see, this deep learning is a one complete subject. Okay, so